Okay, guys, this video is to talk about how vertex form can be changed into standard form and how we can graph both of them. So this is what we've already been talking about, vertex form. So here is an example. Whenever you see parentheses, you definitely know that it's in vertex form. If you don't see parentheses, that actually could be in vertex form or it could be considered standard form, but that'll make more sense later. So looking at this one, I'm hoping that you can tell me that the vertex is positive 2, positive 3. The other thing that this tells us is the A value is 2. So when you have 2, 3 as a vertex, because my A value is 2, I would go over 1 and up 2. And so that would be a pretty skinny parabola, or we say a vertical stretch. The next one here, number 2, my vertex is positive 1, 2. I know it seems backwards of what's in parentheses, but one thing to think about is you want to square a 0. So if you put in a 1, 1 minus 1 is 0, 0 squared is 0, 0 times negative 1 is 0, 0 plus 2, so therefore 1, 2 is my vertex. If I do a quick sketch here, 1, 2, and my A value is negative 1 when you don't see a number. That means from my vertex I go over 1 and down 1, over 1 and down 1. I could also go over 2 and down 4, over 2 and down 4, and so that would be a pretty quick sketch there. Because this touches the x-axis twice, there's 2 solutions. I actually can tell that the solutions would be 0 and 2, because that was a pretty simple one. This one up here, though, it never touches the x-axis, so that means that there are no solutions to that one. Okay, the vertex here would be 2, 0, because there was nothing added on to the end of that. So my vertex is actually on the x-axis. An A value of 1/2 means I go over 1 and up 1/2. So this is a pretty wide parabola. If I wanted more points there, I would have to do like an XY table and plug something else in. I know what's happening at 1, 2, and 3, so I would probably plug in like a 4 or a 5 to figure out where else that is. But you can see here that it only touches the x-axis once, so that means there would only be one solution. Okay, this one here, because there's no parentheses, that means there was no horizontal movement. So 0 is the x-coordinate of my vertex, but this minus 3 moves it down 3. So 0, negative 3 is down here. My A value is negative 1/3. So from this vertex, I'm going to go over 1 and down 1/3. So this is going to be a really wide parabola. If I wanted more points on there, you know, more than just a rough sketch, I would have to do that like XY table, and I would plug something else in. I know what's happening when x is 0 and x is 1, so I would probably plug in a 2 or, you know, a 3, 4, you know, something like that to get a few more points over here. Okay, the next thing that we're going to go over is converting from vertex form to standard form. So I just want you to understand that this equation that starts in vertex form, if I, do the work, I'm going to end up with an equation in standard form. So the very first thing we're going to do here, you got to think order of operations, is exponents. So x minus 4 squared actually means x minus 4 times the quantity x minus 4, and that's a foiling problem. So that's first, outers, inners, and last, and I get x squared minus 4x plus 16. Now that's still in parentheses, and I still have this negative 2 out front, and I still have a plus 5 at the end. So now I'm going to combine like terms inside my parentheses. So I get x squared minus 8x plus 16, still a negative 2 out front, still a plus 5 at the end. Well, now I'm going to distribute. So that gives me negative 2x squared plus 16x minus 32 plus 5. And then the last step here would be to combine like terms. So negative 2x squared plus 16x, and that's going to be negative 27. And don't forget that's, f of x equals or y equals. So up here, I started with vertex form. I could tell just by looking the vertex was 4, 5. And down here I have standard form, and I really don't know what the vertex is just by looking, but these would give you the exact same parabola on the graph. Now something that did not change was this A value here. So the A value of negative 2 is still the A value. And that A value is what makes your parabola, you know, stretch or shrink, makes it wide or skinny, and it flips it upside down. So a -2 A value, that is a parabola that opens down. Because I knew the vertex up here was 4, 5, from that vertex I go over 1 and down 2, over 1 and down 2, and if you wanted any more, you would have to plug them in, but that's just a kind of a rough sketch of what is happening here. So what we need to figure out now is how the heck are we supposed to find the vertex when it's in standard form? So that's what this next week is all about. So this is something that you're going to need to know. You may want to, you know, jot that down somewhere. -b over 2a will give you the x coordinate of the vertex. Okay, the x coordinate of the vertex. So here on problem 1, I need to know what's a b and what's an a. Well, the a is the coefficient of your x squared. The b is the coefficient of your x, and the c is the constant. And we're going to use that ABC idea for like the rest of this time when you guys are, you know, learning Algebra 1 here. So I'm going to do -b, which is -8, over 2a, which is 2 times 1. So this gives me -4. And I like to write this as, you know, in parentheses here, because this is going to be my vertex. -4 is the x coordinate of my vertex, but I still need to find the y coordinate of my vertex. So what do? Don't forget this is an x. So because that's an x, you can plug it in where we have these x's here. So when you're plugging in, you got to remember order of operations. X squared means -4 squared. That's -4 times -4 is 16. 16 times 1 is 16. I like to jot that down. 8x means 8 times -4, that's -32, and then I still have a plus 10. Whenever you're finding the vertex, you're going to notice that these first two numbers, one's always going to be positive and one's negative, okay? And then the first number, 16, is going to be half of the second number, 32. That's always going to happen if you're finding the vertex. So if it doesn't happen, then you kind of know you made a mistake. But I do need to figure out how much this is. So 16 minus 32 is -16. -16 plus 10. So that's going to be -6. So I just found my vertex, which is -4, -6. Now, I'm going to show you how we can take that information and we could graph it just like you were graphing when it was in vertex form. So you start with the -4, -6. Okay, so -4, -6, that's my vertex. Okay, now the next thing you do is you look at your A value. The A value is 1. I love an A value of 1 because that means you go over 1 and up 1, over 2 and up 4, over 3 and up 9, 3, 4, 5, 6, 7, 8, 9. And this is the axis of symmetry. So that means it's 1 on the other side. This is 2 away, so it's 2 on the other side. This is 3 away, so it's 3 on the other side. And so I get all those free points because my A value is 1. Okay, so there is a really nice sketch of my parabola. I already know I'm gonna have 2 answers to this equation because it touches twice. I could estimate and I could say that that looks like it's about -1.5 and maybe -6.5. Of course, those are estimates, but you know, that's pretty close there. Okay, another thing that's really cool about standard form is the C value is actually the y-intercept. So my C value is 10, that means on the y-axis it's 10. Now, normally, you know, you wouldn't need your graph to go that high, but does that kind of fit in? You know, if that parabola would extend, yes, it does. So that is just kind of one more thing that kind of helps us check that, you know, yes, we are getting the right answer. Okay, I'm gonna look at another one here. So number 2. I'm going to start by finding the vertex. So that's -b over 2a. My a value is 2. My b value is 12. My c value is 10. So -b is -12. 2a is 2 times 2, which is 4. That gives me -3. I like to write that in this like ordered pair here because that's the x coordinate of my vertex and I still need to find the y coordinate of my vertex. So I'm going to plug this in. Remember, that is an x. So I'm trying to find a y. So I'm going to plug in -3 squared. That's -3 times -3 is 9. 9 times 2 is 18. I write that number down. 12 times negative 3, that's negative 36. And notice again, 18 is half of 36, one's positive, one's negative. That will always happen when you're working on the vertex. Okay, but I still have that plus 10. So 18 minus 36 is negative 18. Negative 18 plus 10 is negative 8. So I found my vertex. So now, if I go to graph this, okay, no matter what form your equation is in, you want to start with the vertex. So I'm going negative 3, negative 8. Okay, so that's my vertex way down there. The next thing that you do is your A value. Well, my A value is 2. So from my vertex, I go over 1 and up 2. Okay, axis of symmetry tells me that there's, over 1 and up 2 on the other side. Now, that is not enough information for me to, have the parabola. I need one more point. Now, I'm going to go ahead and look at my C value. My C value is 10. Well, that is a y-intercept, so it's way up here, but really what I want to know is I want to know when my x is negative 1. So we should have been doing this before. What I'm going to have to do here is make like an xy table, and I'm plugging in negative 1. So just like I plugged in negative 3 here, you're plugging in negative 1. Negative 1 squared is 1. 1 times 2 is 2. I'm jotting that number down. 12 times negative 1 is negative 12. Okay, and you don't see that, where this is half of this because it's not the vertex. This is just another point. So 2 minus 12 is negative 10. Negative 10 plus 10 is 0. So I just found negative 1, 0 is a point on my parabola. And because this is my axis of symmetry, I also know that that's another point. So that's enough to kind of sketch this parabola. And because that comes out nice and neat, I also know the two solutions. That's a negative 1 and a negative 5. I would get the exact same two solutions if I were to solve this quadratic by factoring or by one of the methods that I'm going to teach you in the future. You always get the same answers there. Okay, I'm going to do one more problem here where I show you how to find the vertex. So that your negative 3 is your A value, your negative 6 is your B value, and your 7 is your C value. So negative B means the opposite of B. So the opposite of a negative 6 is positive 6. So that's negative B. 2A is 2 times negative 3, which is negative 6. Well, simplified, that comes out to a negative 1. And that is the x coordinate of my vertex. So I have to plug that back in. So negative 1 squared is 1. 1 times negative 3 is negative 3. Negative 6 times negative 1 is positive 6. 3 is half of 6. This one's negative. This one's positive. That's always going to happen on the vertex. But then I have plus 7. So negative 3 plus 6 is 3. 3 plus 7 is 10. Okay, so if I come to the graph again, I'm going to put negative 1, 10. So left 1, up 10. That pink looks a lot better than the purple. Okay, so there's my negative 1, 10. Next thing you do after the vertex is your A value. My A value is negative 3, so I go over 1 and down 3. I go over 1 and down 3. Now, the other thing, sometimes it's helpful, sometimes it's not, is the C value. Now, the C value is also the y-intercept. The y-intercept is 7. Well, that's correct, but I already got it from the A value over 1 and down 3. So sometimes it's kind of repetitive and it doesn't really give us any new information. Sometimes it's a really helpful thing to use. Now, if you want another point here, which I would say probably, another set of points would be good. This is when my x is negative 2. This is when my x is negative 1. This is when my x is 0. I want to know when my x is 1. So I'm going to plug in, when my x is 1, 1 squared is 1. 1 times negative 3 is negative 3. Negative 6 times 1 is negative 6 plus 7. So I have negative 3 minus 6 is negative 9. Negative 9 plus 7 is negative 2. So back at the graph, starting at the origin, I go over 1 and down 2. So this is a really skinny parabola. Remember, it's really skinny or it's a vertical stretch whenever your A value is more than 1. Now, I know, the negative is what flips it upside down, but the 3 is what makes it a really skinny parabola, or we say a vertical stretch, because we're stretching it, from top to bottom, it gets really skinny. And that's how we graph when it is in standard form.